Welcome to The Explainer. Today, we're zooming in on one of the most surgically precise killers on Earth. And honestly, the wildest part? It is literally smaller than your thumbnail. We're talking about the Emerald Cockroach Wasp. It's this gorgeous, iridescent, metallic green insect that hides a truly, truly terrifying capability. Okay, let's dive into this mismatch. 10 times. In the animal kingdom, predators usually hunt prey smaller than them, or, at least roughly their own size. But this tiny wasp, it hunts a cockroach 10 times its own size. To put that into perspective, that's like you or me trying to wrestle a minivan. So how on earth does a creature conquer a giant 10 times bigger than itself? Well, it doesn't use brute force. It relies on something much, much more sophisticated. Section 1. The impossible hunt. A target built for survival. Picture the warm, tropical forest floor. Gliding right at ground level through the leaf litter, the cockroach is basically built like a tank. It has this incredibly robust nervous system that's biologically engineered to survive just about anything the environment throws at it. It's heavily armored, it's fast, highly reactive, almost indestructible. Actually, scratch that, it is indestructible if you attack it head-on. So how does the wasp win? Well, the goal isn't death. If it tried a frontal assault to kill the roach, it would absolutely lose. Instead, it bypasses the armor entirely for a hostile takeover. The wasp's goal is to completely hijack the roach's mind. It wants to turn this indestructible tank into a living, breathing puppet. Section 2. The two stings. Surgical precision. Now, what's really interesting about this next sequence is how the wasp actually pulls off this absolute masterclass in mind control. It executes a perfect two-part chemical attack. Step 1 is really just a tactical maneuver. The wasp delivers a quick initial sting just to temporarily hold the massive roach still. It only buys the wasp a few precious seconds, but honestly, that is all it needs for Step 2. Because Step 2 is the masterpiece. The wasp extends its stinger and injects venom directly, and I mean with microscopic, literal pinpoint accuracy, into a highly specific brain region of the cockroach. This one spot is the exact cluster of nerves controlling the roach's escape reflex. The wasp knows exactly where to sting. It's a level of biological precision that is it's almost hard to wrap your head around. Section 3. Paralysis of will. The hijacked mind. The aftermath of this strike is, well, it's honestly chilling. We don't see a dead roach, and we don't see a violently twitching roach. Instead, we get this eerie, docile stillness. The now zombified cockroach just stands there, calmly grooming itself. It's breathing, it's alive, but something fundamental has just been switched off. And this brilliantly illustrates the difference we're talking about here. Usually, when we think of venom, we think of physical paralysis, right? A complete loss of muscle function where the prey physically cannot move. But contrast that with what the wasp has actually done, a paralysis of will. The roach's body isn't paralyzed, its muscles work perfectly fine. It has completely retained its ability to run away. What the wasp has paralyzed is the decision to leave. It just turns off the will to run. Which leads us to this deeply unsettling behavior known as the leash. Because the roach's physical body works fine, but its will to escape is just completely gone, the tiny wasp doesn't have to drag a body 10 times its size. Researchers have watched this happen, and the wasp simply grabs the roach by its antenna and literally walks it. Like a person walking a dog on a leash, the wasp leads its giant prey straight toward its burrow. And the roach, it just quietly, obediently follows along. No resistance at all. Section 4. The neuroscience connection, from forest floor to the lab. So, stepping out of the tropical leaf litter and into the bright, clinical lighting of a laboratory, we find teams of researchers actively using this as a model. Because, you see, this bizarre predator-prey dynamic isn't just a biological freak show, it's a puzzle. Neuroscientists are trying to map exactly how this tiny insect manages to find one precise cluster of neurons. Think about the scale here. Inside the already microscopic brain of a cockroach, the wasp stinger acts like a guided missile, completely bypassing everything else to find one specific neural switch. It's a level of targeting that completely baffles our current understanding of insect neurology. And here is why this matters to you and me. Let me read this. Understanding how a wasp finds one exact neuron cluster could inform how we design targeted treatments in far more complex systems. If scientists can actually unlock the mechanism behind this wasp's precision targeting, how it maps that small brain to find one single node, it could be a total game changer for medicine. It could directly inspire how we design advanced, highly targeted pharmaceutical treatments for the human brain. Imagine being able to hit specific neuron clusters without affecting the rest of the nervous system. So yeah, from a tiny green wasp to the future of human neuroscience. Section 5. An uncomfortable question, the illusion of choice. Pulling back out to the macro level for a second, stepping away from the lab and back into the soft evening light of the forest, the tiny wasp and the massive, docile roach finally reach their destination. They disappear into the dark entrance of the wasp's burrow. But before the shadows close over them completely, let's just recap the sheer psychological control we've just witnessed. Down in that burrow, the roach still has working legs. It still has fully functioning muscles. There are zero physical barriers holding it down or tying it up. Literally nothing is stopping it from turning around and walking right back out into the light. It just doesn't want to anymore. Its reality, its very desires have been chemically overwritten. Which leaves us with this final thought. Is that so different from choices we make when something has quietly rewired how we feel? When our environment or chemicals or external pressures quietly shift our perspective? How much of our will is truly our own? It's definitely something to think about. If this kind of quiet, precise weirdness gets you thinking, be sure to subscribe to The Explainer. We drop new deep dives into fascinating topics just like this every Wednesday and Saturday.